This recording is to help you with lesson 3.03, Properties of Logarithms. Alright, we're going to start off with using the change of base formula. Now, using the change of base formula works with logarithms and natural logs, and you can interchange them here. So what we need to remember, though, is that the base for natural log is e. Right? So really we can say the natural log of base e of 5. Now, how the change of base formula is going to work is you're going to split these up into two different parts. Your numerator is going to be the natural log of 5, and your denominator is going to be the natural log of your base, which in this case is e. Right? And you can work that out with log too, because essentially what this is saying is you're going to multiply. So you'd be left with log base 10 of 5 over log base 10 of e. So either one of these is acceptable for your answer using the change of base formula. Now what do we get using the change of base formula here? And you will need your calculator. You would get the log of base 10 of 4 over the log of base 10 of 1/2. Now the whole purpose of the change of base formula is so that you can use your calculator. You are putting things into base 10, which is what your calculator understands. Right? So we would do log 4 divided by log of 1/2, or you can use natural log of 4 and natural log of 1/2. They're interchangeable there. Either way, you will get the same answer of -2. Next, let's rewrite these as using properties. So the square root of z is also known as z to the 1/2 power. Now we know that our property states the exponent can be pulled out front. So that's the same thing as saying 1/2 times the natural log of z. The next one, let's start by separating your multiplication here. And we know that we can separate multiplication by adding. So we can state that the natural log of z plus the natural log of z minus 1 squared. Well, we can't leave the exponent there, so the next thing we need to take care of is that exponent by bringing it way out front. And we would have the natural log of z plus 2 times the natural log of z minus 1. Number 50, now we need to condense it. Let's take care of the numbers out front and change them to exponents first. So that would be the natural log of 8 squared plus the natural log of z to the 5th. We all know that 8 squared is 64, so I'm going to change that. Let's get rid of the adding. So if we're working backwards, adding will then change into multiplication. So then I have natural log of 64 times z to the 5th. All right, let's condense this possibly. Okay, we don't have any numbers out front to put up as exponents, so let's just worry about that subtraction sign since they're both log base 5. Subtraction, I can change that to division, so 75 divided by 3. Well, 75 divided by 3 is 25. Let's see. That should still be base 5. All right. Let's see if I can rewrite 25, so if there's any way I can cancel out the log base 5. 25 is the same thing as 5 squared. Now I can bring that exponent out front. So 2 log base 5 of 5. And I know that log base 5 of 5 just is 1. So that's a property there. So 2 times 1 equals just 2. For 85, let's see if we can solve this. Well, division, if I'm going to separate the division, that is subtraction. So log base 5 of 1 minus log base 5 of 250. Anything of log base 5 of 1 or log base 10 of 1 or anything with the base to the 1 is 0. Right, so that was one of the properties there. So 0 is now replaced or substituted in, and I have to rewrite 250. I'm going to rewrite 250 as 125 times 2, because in the back of my head I'm thinking, well, if it's base 5, I want to be able to change something so I have 5 to a power. All right? And in my head, I'm thinking, well, 125 is the same thing as 5 cubed. So if I write it this way, I now can separate this. Multiplication is separated with a plus sign. And I have log base 5 of 5 cubed, which is just 3. Right? Because you can bring the 3 out front. And log base 5 of 5 simplifies to 1. And that's what's shown right here. Then you're still left with log base 5 of 2. Nothing can happen with this log base 5 of 2. There's no way you can simplify that. Right? So if that's gone, you're just left with negative 3 minus, because I'm going to distribute some negative sign here. So minus log base 5 of 2. The next and last one we're going to go through is number 90. It says students participating in a psychological experiment attended several lectures. After the last lecture and every month of the next year, the students were tested to see how much of the material they remembered. The average scores for the group are given by the memory model there, where T is the time in months. And that's important to note, that T is the time in months. Part A is just graphing it on your graphing calculator. I'll let you guys do that on your own. Part B, though, what is the average score on the original exam? So what do we get when T equals 0? So when we plug 0 in for T, let's see, we get 90, and you can use your calculator here because it is base 10. 90 minus 15 times log of 1. So 90 minus 15 times log of 1 gives me just 90. Good. What do I get when I plug in 6? 90 minus 15 times log of 7. So approximately what? 77.32. When I plug in 12, I get 90 minus 15 times log of 13. And that is 73.291. And then the last one, when would the average score have decreased to 75? Now this is where we're actually going to have to solve. We plug 75 in for f of t, and now we need to actually solve for t. So I'm going to start by subtracting 90 from both sides to get the following. Divide each side by negative 15. And then let's change this to an exponential form. So that is 10 to the first power equals t plus 1. So 10 equals t plus 1. Subtract 1 from each side to get t equals 9. So at about 9 months, your score is going to decrease to 75. Let's check our answers, and hopefully they line up here, and they do.